Alright, we're starting with the roof girder now. If you haven't taken a look at the roof beam solution, make sure you do so before moving on to this one, because we're going to use information from that member. We could start by identifying a tributary area like we did in the past, but we're not going to use that value for anything because the only reason we found it on the floor girder was to reduce the live load. We can't reduce because we're on the roof, so we don't need to bother finding that tributary area. If you're curious, it looks identical to the floor girder tributary area. So let's start by figuring out what sort of loads are happening on this girder. Right. We have a girder that is 24 feet long. All right, this is girder B. And it's going to have these beams framing in at 2 points, and those points are located at every 8 feet. So here we have a point load, here we have a point load, and this 24 feet is split into thirds of 8 feet apiece. Right. So we're going to have a concentrated dead load and a concentrated snow load from the roof beam, right? Because we only had dead and snow on that roof governing. All right, so we're going to have these values. We're also going to have a distributed load due to self-weight, Q self-weight. All right, it's a dead load only. So that's what our girder looks like. In order to get to these concentrated forces, right, we're going to have to look at what was happening on that beam. So let's look at the loads from the roof beam. Alright, here is my beam. It only had distributed load. That distributed load was Q sub S, Q sub D, and this beam is 25 feet. Right, this is the beam. What I care about from the beam is the reaction as it hits that girder. So I care about these two reactions. Right, a reaction due to the dead distributed load and a reaction due to the snow. Right, so I can calculate those. The reaction at D is just going to be 1/2 Q sub D, which is 0.47 kips per foot, times the length of the beam of 25 feet, gives me 5.88 kips. If you have no idea where this number is coming from, the 0.47, go look at the roof beam solution. Right, that is the distributed load we found on that member. You can calculate the reaction on the snow as well. 1/2 0.32 kip per feet times 25 feet kip per foot, I should say, is 4 kips. Alright. So we have the reactions. We know we already have the self-weight given to us. We need to calculate this PD and this PS, those actual concentrated forces. So let's look at the dead load first. Actually calculate P sub D. Right. From the beam, P sub D is going to be 2 times R sub D. Right. It's simply 2 times, not because there's 1, 2 along the length. Right. 1, 2 along the length. It's because I have this beam A framing into that point that has a reaction of RD, and I have this beam framing it at that point, point 1, causing the reaction RD. So 2 of them, each with their own reactions equal to RD, are framing in at 1 point. So that is why I'm multiplying by 2 right here. Alright, so that is going to give me 11.8 0.8 kips. From the self-weight, I have Q sub D self-weight is equal to 50 pounds per foot, or 0.05 kips per foot. I've got my dead load. I need my live load. This is coming purely from the beam. It's those concentrated loads. Again, this is P sub S for snow. And we have 2 times R sub S, which is 2 times 4 is 8 kips. Alright, so I have P sub S, P sub D, Q sub D self-weight. Alright, that's exactly the loading I have on the drawing for my girder. So all I need to do now is calculate some moments to plug into my LRFD equation. Alright, so I'm going to find some design moments. I have M sub D. Alright, I need to deal with the fact that I now have point loads at every third of the span, as well as the distributed load. So if you look back at our floor girder, we had to add the 2 maximums. We had to add Q L squared over 8. Alright, that's our maximum from the parabolic moment diagram, plus the maximum due to the point load moment diagram. That maximum was PL over 3. Right, we have a moment due to point loads and a moment due to distributed load for dead. Let's plug all this in. 0.05 kips per feet times 24 feet for the girder over 8 squared, plus 11.8 kips times 24 feet over 3 gives me 98 kip feet for the dead moment. I also have a live load moment, and here I simply have the concentrated load, so I only need to include that portion of the moment equation. I have 8 kips times 24 feet for the girder over 3 gives me 64 kip feet due to live load. This is not live. Sorry, this is snow. Alright, very last step. Let's plug into our load combos. Just like we saw before, if we only have dead and snow, we only need to check load combo 1 and load combo 3. This one is going to give me 137 kip feet. This one is going to give me 220 kip feet. So our M sub U for the girder, the moment that we are going to design for and make sure our structure can carry, is 220 kip feet, the larger value of these two.